Imagine holding a toy in your hand, knowing you made it yourself. Not just built it, but actually created it from scratch. That's the power of 3D printing. It's like having a mini factory right on your desk, but instead of metal and screws, we use plastics, resins, and even powdered metals. 3D printing, also known as additive manufacturing, is changing how we make things. It's a revolutionary technology that builds three-dimensional objects layer by layer from a digital design. Forget traditional factories with their bulky machines and limitations. 3D printing allows us to create complex shapes and intricate designs with incredible precision. From toys and jewelry to medical implants and even rocket parts, the possibilities of 3D printing seem endless. It's a game changer for industries like healthcare, manufacturing, and art, offering innovative solutions and pushing the boundaries of creativity. So buckle up. We're about to embark on an exciting journey into the world of 3D printing, exploring how it works, its diverse applications, and its potential to revolutionize the future of manufacturing. Have you ever wondered how a 3D printer takes a digital design and turns it into a physical object? It's like magic, but with a lot of science and engineering behind it. The process starts with a digital model, created using computer-aided design or CAD software. Think of it as a blueprint for your creation, containing all the information about its shape and dimensions. Next comes the slicing. Just like slicing a loaf of bread, the 3D printer software divides the digital model into hundreds, sometimes thousands of thin layers. Each layer represents a cross-section of the final object. Now, the printing begins. The 3D printer follows the sliced layers as a guide, depositing material layer by layer, slowly building up the object from the bottom up. Imagine a pastry chef meticulously layering cake batter and frosting to create a stunning multi-tiered cake. That's essentially what a 3D printer does, but instead of delicious treats, it uses materials like plastics, resins, or even metals. As each layer is deposited and hardens, it bonds with the layer below it, eventually forming the complete three-dimensional object. This additive manufacturing process is what sets 3D printing apart from traditional manufacturing methods that often involve cutting or molding materials, leading to more waste. With 3D printing, we build objects precisely, layer by layer, minimizing waste and maximizing efficiency. Just like there are different ways to bake a cake, several 3D printing technologies exist, each with its unique approach to creating objects. Let's explore three popular methods: FDM, SLA, and SLS. First up, we have fused deposition modeling, or FDM. This method is like using a hot glue gun. FDM printers use a thermoplastic filament, a thin plastic thread wound around a spool. The filament is heated until it melts and extruded through a nozzle onto the build platform. The nozzle moves precisely, following the sliced layers of the digital model, depositing melted plastic like a tiny, intricate hot glue gun. Next, we have stereolithography, or SLA. Imagine a vat filled with liquid resin, sensitive to ultraviolet or UV light. SLA printers use a UV laser to selectively harden the resin, layer by layer. The laser traces the shape of each layer onto the resin surface, curing it and solidifying it. The platform then lowers, submerging the cured layer into the resin bath, and the process repeats, building the object upside down. Finally, we have selective laser sintering, or SLS. This method uses a high-powered laser to fuse tiny particles of powdered material, like nylon or metal, together. The laser selectively scans the powder bed, sintering the particles according to the digital model's layers. Unsintered powder remains as support, eliminating the need for separate support structures. Each 3D printing method has advantages and disadvantages, making them suitable for different applications and materials. FDM is great for beginners and prototyping, while SLA offers high resolution and smooth surface finishes. SLS excels in creating durable and complex parts, even using metals. The magic of 3D printing lies in the variety of materials it can use. From everyday plastics to advanced alloys, the material palette is constantly expanding. Plastics are the most common, especially in FDM printers. PLA is popular for its ease of use and eco-friendliness. SLA printers use photopolymer resins for high-resolution prints. SLS printers use powdered materials like nylon and metals. Metal powders create strong, lightweight parts for aerospace and automotive industries. The expanding range of materials opens up endless possibilities for 3D printing. Section 5.3. D. Printing in Action Transforming Industries. From healthcare to manufacturing to art, 3D printing is transforming industries. In healthcare, it revolutionizes patient care with custom models and implants. Manufacturing benefits from rapid prototyping and complex designs. Artists and designers embrace 3D printing for intricate creations. The transformative potential of 3D printing is just beginning. Section 6. A sustainable solution. Reducing waste with 3D printing. In a world grappling with environmental concerns, 3D printing offers a glimmer of hope as a more sustainable manufacturing solution. By minimizing waste and promoting localized production, 3D printing has the potential to transform how we produce goods and consume resources. Traditional manufacturing methods often involve subtractive manufacturing, where materials are cut away from a larger block, leading to significant waste. 3D printing, on the other hand, embraces additive manufacturing, precisely depositing material only where it's needed. This precise layering process minimizes material waste, reducing the environmental impact associated with discarded materials and their disposal. Furthermore, 3D printing promotes localized production. Instead of relying on centralized factories and long resource-intensive supply chains, 3D printing allows businesses to manufacture goods closer to their customers, or even on demand. This distributed manufacturing model reduces transportation costs, emissions associated with shipping, and the need for large warehouses and storage facilities. Imagine a world where you could walk into a local store and have a custom pair of shoes printed right there, reducing the need for mass production and the environmental costs associated with it. While this may seem like a distant future, the potential for 3D printing to revolutionize manufacturing and reduce our environmental footprint is undeniable. As awareness of sustainability grows, 3D printing stands out as a promising technology to create a greener future. By minimizing waste, promoting localized production, and enabling the use of recycled and eco-friendly materials, 3D printing paves the way for a more sustainable and responsible approach to manufacturing. Section 7. Ethical considerations, the dark side of innovation. 3D printing holds immense promise, but it's crucial to acknowledge the ethical considerations and potential risks. This technology can be used for both good and bad, raising concerns about unregulated use. One major concern is the potential for unregulated weapon creation. This raises public safety concerns and the need for stricter regulations. Another concern is job displacement due to automation. However, technology also creates new opportunities in industries. Intellectual property rights are also a concern with 3D printing. Robust legal frameworks are needed to protect intellectual property. Open discussions and clear guidelines are essential for responsible use. By addressing these concerns, we can harness 3D printing for good, driving innovation while mitigating risks. Section 8. The future is now, 3D printing's limitless potential. As we stand on the cusp of a new era in manufacturing, 3D printing has emerged as a game-changer, a technology with the potential to revolutionize industries, solve global challenges, and unleash unprecedented creativity. From personalized medicine and sustainable manufacturing to space exploration and beyond, the possibilities seem limitless. Imagine a future where we can print custom-designed organs for transplantation, eliminating the wait for organ donors and saving countless lives. Picture a world where we can manufacture products on demand, reducing waste, and minimizing our environmental footprint. Envision a time when we can 3D print entire buildings, habitats on Mars, and even intricate works of art that defy imagination. While these possibilities may seem like science fiction, they are within reach, driven by the relentless pace of innovation in 3D printing technology and the expanding range of printable materials. As researchers and engineers continue to push the boundaries of what's possible, we can expect to see even more groundbreaking applications of 3D printing in the years to come. The future of 3D printing is bright, filled with opportunities to improve our lives, address global challenges, and unleash our creative potential. By embracing this transformative technology responsibly and fostering collaboration between innovators, policymakers, and the public, we can shape a future where 3D printing empowers us to create a better world for all.